Let's talk about finding the sample mean, the margin of error, and the required sample size for a confidence interval. A 95% confidence interval for the mean number of pets in the households of college students is 0.96 to 1.84. I did not make up those data. That's based on a survey I did of my stats classes. Find the sample mean. When the population standard deviation sigma is unknown, the endpoints of the confidence interval will be x bar plus or minus t sub alpha over 2 s over square root n. In other words, it's going to be x bar minus t sub alpha over 2 s over square root n to x bar plus t sub alpha over 2 s over square root n. So the sample mean, x bar, is going to be right in the middle of the interval, smack dab in the middle. That means that x bar is going to be the mean of the endpoints. So x bar is 0.96 plus 1.84 over 2. In other words, 1.40. That's the mean, the average of the endpoints. Find the margin of error. Again, the margin of error is the distance from the middle of the confidence interval to the endpoint of the confidence interval. The middle is x bar. We just saw that a moment ago. And the confidence interval looks like this. X bar minus this stuff to x bar plus this stuff. So the distance from the middle of the confidence interval, namely x bar, to the endpoints of the confidence interval, well, if x bar is in the middle, and this is an endpoint, x bar plus t sub alpha over 2 s over square root n, that means the distance between those must be t sub alpha over 2 s over square root n. So the margin of error is t sub alpha over 2 s over square root n. And that's also going to be the distance from x bar to x bar minus t sub alpha over 2 s over square root n. Well, the problem is that we don't know t sub alpha over 2 s, we don't know n, we don't know any of that stuff. But to be honest, in this particular case, we don't need any of that stuff. The margin of error is the distance from the middle of the confidence interval to the endpoint. Okay, we already know what the middle is. We just saw a moment ago the middle is 1.40. That's right in the middle of this interval. And the endpoint, or at least one endpoint, is 1.84. So the margin of error is 1.84 minus 1.40, which is 0.44. That's also going to be the distance from 1.40 to this endpoint of the confidence interval. So the margin of error is 0.44. The margin of error is 0.44. Find the sample size that would be required if we wanted the margin of error to be 0.1. In other words, 0.44 is a pretty big margin of error. We want to make it smaller. Well, in this particular problem, you need some more information. It turns out that x bar is 1.40, s sub x is 1.50, and n is 47 students. If with all of this information, you'd be able to calculate this. I just didn't bother to go through the calculations. I just told you what the confidence interval is. So because the endpoints of the confidence interval are x bar plus or minus t sub alpha over 2 s sub x over square root n, margin of error is, as we saw earlier, the margin of error is going to be epsilon equals t sub alpha over 2 s sub x over square root n. So let's solve this for n. In other words, let's get n by itself and let's express n in terms of everything else. Just a little bit of 8th grade algebra. So the size of a sample required is n equals t sub alpha over 2 squared s sub x squared epsilon squared, where again epsilon is the margin of error. So n equals t sub alpha over 2 squared, we'll calculate in a moment, s sub x squared, s sub x we saw was 1.5, and epsilon squared, that's 0.1. So this is what we end up with for n. Last thing we need to do is calculate t sub alpha over 2. So let's look at the t-distribution table. This again is what we use when we don't know the population standard deviation sigma. We can find it in the textbook. It's a table in the appendix of our textbook. If you have a physical textbook, you can find it at the back. Or if you have an electronic copy, you just go to MyLab, Statistics, Pearson eText, then choose Table of Contents and Appendices. But you can avoid all of that just by entering T-table into a search engine. That's good enough. So you're going to end up with something that looks like this. And here's how we'd find t sub alpha over 2. So first we need to find the column. Again, we want the two-tail probability to be 0.05. So we want this column because it's a 95% confidence interval, which means the stuff that's left over, the significance level is alpha, which is 0.05. So we want this column. The row is going to be df, the degrees of freedom, and that's going to be n minus 1. We have 47 pieces of data, so 47 minus 1, the degrees of freedom, is going to be 46. Now, when we're dealing with degrees of freedom, we always round down. So 46 is not in the table, so we got to go with 45. Even if we had 49, we would not round up to 50. We would just have to round down to 45. We always round down when it comes to degrees of freedom. So in this case, we want 2.014. That's the value that's in this row and this column. Let's plug that in. N equals t sub alpha over 2 squared, 1.5 squared, 0.1 squared. In other words, 2.014 squared, 1.5 squared, 0.1 squared, and that turns out to be 912.6. When calculating sample size, we round up to the next integer. So we don't round to the nearest integer, we round up to the next integer. Even if this were 912.1, we would still round up to 913. We need 913 students. That's a pretty sizable number. That's why we usually don't have such small confidence intervals. Now, in the previous example, the population standard deviation sigma was not known. If the population standard deviation sigma is known, then the size of the sample required is n equals z sub alpha over 2 squared sigma sub x squared epsilon squared, where z sub alpha over 2 can be found in this chart. Notice the only difference between this formula and the previous one is that z is replacing t. We're using the normal chart and not the t-distribution chart. And we don't have an s. Instead, we have sigma because we know sigma. So, yeah, in this case, you would just grab z sub alpha over 2 from this chart. There's a way that you can get it from a normal chart as well. By the way, 3 dogs, as long as we're talking about pets, 3 dogs survived the sinking of the Titanic. 2 Pomeranians and a Pekingese. It's not like they had to, it's not like the owners chose to bring on dogs as a way of displacing other passengers. These are small dogs, and their owners brought them on board the lifeboats amidst the chaos.